See the go live.
Yeah.
Hi, everyone. Thank you so much for joining us today for another episode of Decoded. Today, we're very excited to have Ashwin Suresh here to discuss his work for Isom Waste Care. The premium skincare product is made of wastewater from Aisome's textile dyeing factory. In fact, Wastecare is the very first skincare product that is made from industrial waste. The brand recently took home a prestigious Golden Lion at the Cannes International Film Festival of Creativity. And with that, I'm excited to hand over the show to Ashwin. But before I do, don't forget to add your questions into the Q&A box because there will be a question and answer session at the end. All you, Ashwin.
Awesome. Thank you for the introduction. I'll just share my screen now. Okay, great. So yeah, thank you for the introduction again. My name is Ashwin Suresh. I'm currently working in a design agency called Fluid Design, and I'm currently based in Munich. And today I'm super grateful to have the opportunity to talk about the design story for the Aizome Waste Care project, and along with it, my design process, and share some behind the scenes material with you. So as an industrial designer, my day-to-day is to follow a creative design process and use a wide range of tools like research, to sketching, to CAD programs, to come up with physical products and solutions. But one big role that you would play as an industrial designer is to make sure your designs are manufacturable and are feasible in the real world. So it's not just making aesthetic shapes and product concepts, but it's also to think about physical interactions to make sure that these designs are feasible and ergonomic, so that it can be manufactured and used by potentially millions of people. And a while back, I had the opportunity to work on the packaging for the Aizome Waste Care project as an industrial designer in close collaboration with the service plan innovation team. So I'll now start off by playing the trailer for the Waste Care project.
79% of skin diseases worldwide are caused by toxic chemicals used in textile production. Japanese textile startup Aizome has developed a method to produce textiles that are not only harmless, but even come with additional health benefits. And because only plants, water, and ultrasound are used, even the wastewater is good for you. Introducing Wastecare. Industrial waste certified as skincare. Straight from the factory, the wastewater is tested, bottled, and packaged using recycled materials only. Discover the whole story. Experience the benefit. Get in touch.
According to the United Nations, the textile industry is the second largest cause of water pollution. And the leading cause of that is the dyeing process, which uses a lot of chemicals, which is not only harmful for the environment, but it's also extremely irritable for your skin. So that is why Aizome developed Aizome Ultra, which is an innovative dyeing process that uses only plants, water, and ultrasound to bind the dye to the fabric without using any synthetic chemicals. So because of that, the waste and the byproducts that's produced from the dyeing process is not only not harmful for the environment, it doesn't contain any chemicals, but it's also beneficial for the human skin. So the wastewater was shown to have anti-inflammation, pain relief, and skin rejuvenation effects. So as a testament to the sustainable dyeing process, Aizome launched Wastecare, a premium skincare product that is the wastewater collected as a byproduct from their dyeing process. And then Wastecare was sent out to key opinion leaders in the textile industry to highlight the damage caused by conventional dyeing methods. So I had the opportunity to work on the packaging for the wastewater, also the lid of the vial that contains the wastewater. So today I'll be doing a deep dive into the design process for both of these objects. So the design of the packaging, it started off with a simple 6x6 grid system, which was proposed by the design studio Work by Works. And the idea is that the three colors that you see in the background are three documents that are included in the packaging to explain the story of the Aizome Ultra. This grid system would be used as a neutral canvas upon which everything from text to data visualization and the contents of the packaging will be based on. And this grid system will be physically present in all the documents. So using those grids, the 6x6 grid, holes will be punched across all the documents. So for example, what you see here is a template of a poster that will be included in the packaging. And this poster would be folded to a sixth of its size. And then the black dots you see here are actually holes that were punched in after it was folded. And these contents, so that's the documentation, the vial of the wastewater, and a fabric sample would all fit inside a box. And the interesting thing is we wanted to create guides that would hold all the documents together using the punched out holes in them. So on the top of this image, you can see there are these pins or these extrusions which pass through each document and hold it in place, which is and it's neatly arranged in the box. And that was the initial idea that I had to build from. But some other important points that I had to keep in mind was also sustainability was a core value in this project. So every step we took, every decision we made had to be aligned towards that. And then next, the packaging is not just something that holds all these contents, but it's also something that communicates the wastewater story to the viewer. And part of the story is the ultrasound process. So we wanted to have some visual cues or metaphors of this process in the packaging itself. And then for the final value, overall, we had a vision to make something simple, honest, something that communicates the story in a very direct manner. So what I like to do once I receive a brief is to put down a bunch of ideas on paper. So I already started to think of different things that we can do that fits these conditions. And you can also see that these are very rough sketches. They're almost like doodles. So at this step, it's safe to say that in my mind, it was quantity over quality. So I just wanted to make sure that I can cover as many different avenues as possible in the initial step. And at this stage, things were kept open-ended very intentionally, so that maybe we try 10 different things, but out of that comes out one idea, which could be the MVP. But we already saw some ideas that seemed promising. For example, we were thinking about slice form volumes, which is like volumes created with flat cut out pieces of a flat sheet of material. We were thinking about molded pulp. And another idea was to maybe stack layers of cardboard together to get like a sturdy volume with a depth effect. And we were also thinking maybe you can use the fabric as a functional piece in the packaging and so on. And initially, we actually really liked the idea of using pulp in the packaging. And because with pulp, we can achieve different textures, it's durable, it's sustainable. And I had this idea of maybe molding the pulp to make it look like fabric. And this was something that really stuck in my mind. But the thing is, using paper pulp, it requires a mold. You need to put the wet pulp into a mold and then press it. And this mold could be expensive because you need one mold, which usually which is usually an intensive process to make the mold itself. And this would be expensive and is not really sustainable in low qualities. But if you think of something like an egg carton that you see in the market, then you can make millions of these out of one mold. So it is still a sustainable process, but it didn't really fit what we were trying to do. So then we started thinking about sheets of material. And the first thing that could come into our minds is cardboard. And of course, cardboard is sustainable, but even apart from that, it's actually a really nice material to work with, because cardboard, in its simplest form, it's two sheets of thick paper with a wavy piece in the middle. And this wavy piece is called corrugation. And this corrugation makes it strong and very versatile, especially for its price. And the cherry on top was that if you see the image on the bottom right, this of a sound waveform. This relates back to the ultrasound story in a way, because the waveform kind of looks like the corrugation that's used in the cardboard. So yeah, since we had a narrower direction now, I started making more solid concepts. So compared to the doodles from before, these were more detailed. So these showed more interactions and different things that the viewer would do when they unbox the package. So in this study, for example, you can see I've used the slice form method to maybe make a lid that would go over the contents of a box that would contain all the documents and the vial of wastewater. Or in this idea, I was thinking of plotting different layers of cardboard and then sticking it together, and the shapes together would form a sleeve into which the contents and the packaging can be slid into. And at this stage, I was getting more confident with what we can do with this material, like in terms of manufacturing processes and so on. And after a few more of these explorations, it was time to make more solid concepts where every single detail would be thought through. And I find that adding more fidelity to the way in which you communicate the idea is also a good way to add more detail to the idea itself. So as we move to the final stages, I started creating these digital sketches, which communicates the idea in a different level. And the nice thing was, since the idea is communicated in much higher detail, we could already go to our producers and manufacturers very early on in the process and show these ideas to get their feedback. Because they may not understand hand sketches the same way a fellow designer would, especially for something that is so conceptual. So it's nice to show them something more tactile, maybe with colors, materials, finishes, and so on. But this is also where we started realizing that we were getting a bit carried away. Like we started getting into the different things that you can do with cardboard, and then we realized that you can either make something that's really cool, or very easily you can make something that's visually overwhelming. So I think this is the stage where I had to remind myself of the initial, the starting points that we had, and that we had to make something more simple and straightforward. So from this stage, even though we didn't have a concept that was set in stone, I already started playing with different tools that was available to us. So it was kind of amazing to see all the tools out there. Like this one, it was a program that I found. It was a free program that I found online, where you can give in any 3D volume, and it would slice it into different, into different sections, basically in different ways too. Like on the right side, you see a slice form. On the left side, it's like a stack. And then you can export this as a ready to cut, like a file basically. And this, you can do it with cardboard, paper, plywood. So it was quite fun discovering all these different tools. That was quite amazing. And yeah, and now that we're getting closer to the end of the design process, it's a good time to talk about tolerances, because this was a huge factor when it came to making these designs real and manufacturable. And if you're a designer, especially like an industrial designer, chances are you've probably already worked with tolerances. But I still thought I would give you a quick explanation, and I made some quick technical diagrams. So in this slide, you can see there's an object on the right, and then there's an object on the left. And let's say the one on the right has to go inside the one on the left. And let's say both the object and the hole is 6 millimeters wide. So you would think that it would slide in. But in the real world, there's always an overlap of material that happens exactly where the object and the hole gets to 6 millimeters. But in this case, you can see that the hole has a bit of an extra gap, so 6.2 mm on the side of the hole. And this gap is what you call tolerance. So this makes it possible for the object to slide in pretty easily. 0.2 mm is sort of a rule of thumb that you would use when you prototype with plastic. But when it comes to metal, especially if it's like a really well-machined metal, it can be much lower than that. But when it comes to cardboard, the tolerance of the material I found happened to be super vague because cardboard bends, it deforms, it tears. And we were doing so many different things with the cardboard that it was hard to come up with a fixed number that works in all the cases. Um, so I realized that I had to keep tweaking the tolerance of the shapes or the cutouts according to different factors. So, for example, what's the purpose of the cut itself? So sometimes we would be bending the cardboard, sometimes we would squeeze something in between, sometimes we would stack it, and depending on all of this, the tolerance would have to be different. Um, and the second point, it's kind of interesting, is that cardboard has a unique property. It almost has like a grain, like in wood, in that the orientation of the corrugation in the cardboard that you work with really affects the outcome. And this also affected the tolerance, like yeah, how you cut it and so on. And then depending on the type of the cardboard, the thickness varies depending on the standard that you use. And of course, when you stack it, you have to multiply that thickness with the number of layers. And this also like played a very important role when it comes to tolerance. So while we were at our producer's workshop, we saw the sample, which was exactly what we were thinking of when we were thinking about stacked layers of cardboard. And we found out that this is actually a very durable and a cheap process for packing technical components in a safe way for transport. And this wasn't a fancy or a luxurious process at all, but we really felt like this really went with the story of the product itself. Like it's simple, it's honest, and it's very straightforward. And another constraint that we had set for ourselves was that the entire packaging would be shipped as it is. We don't want yet another box on top of this, which may possibly have some plastic tape or some sort of unsustainable materials, which we cannot control. So we wanted this packaging to be the one that will be shipped itself. And at this stage, the dimensions of the contents were fixed. We had a good idea of the manufacturing processes we would use, and we had a final idea to work with. We also ran a lot of tests on the cardboard where we experimented with laser etching, painting, and a few other methods. I personally really like this method where we could cut halfway into the cardboard and then peel out the first layer, and this makes the corrugation show through. I really like this because it felt like it adds a lot of depth to the material used for the packaging, and it's a great way to communicate the importance of cardboard in this story. But yeah, coming back to our initial idea, we wanted to have a structure based on the grid system that can hold all the contents in place. And we were looking for different ways to manufacture such a piece in low scale. And we thought that 3D printing was a viable option at first because it doesn't require molding, it's relatively cheap in low scale, and so on. So what you see here is actually a test template that we tried out, where we tried out a bunch of combinations of the structure to test the material. And this test had a lot of variables, like the radius of each extrusion, the different treatments on the edges using chamfers or fillets, how the cutouts would behave in different depths, and so on. And overall, this was pretty successful in terms of manufacturability and durability. But there was one key reason why we didn't end up using this method, because we realized that this would be the only plastic piece in the packaging, and this really didn't feel right. So we took a short step back and we tried to rethink the process of making these structures inside the box itself. And we realized that if the same holes from the grid system were repeated on the cardboard and the holes go all the way through the box, then we can pass some sort of shape through it, like an extrusion through it, and this would be strong enough to work as a support itself. And we were trying out different things, and what worked the best was these paper sticks, like rolled paper sticks, which is usually used as sticks for a lollipop. So in this image, you can see how we tried it out with some white sticks, but at the end, we were also able to source some brown unbleached sticks, so that fit in the rest of the packaging as well. And initially, the plan was to fill the entire 6 by 6 grid with these sticks, with the structure. But we realized that putting the documents back into the box would be quite difficult. So, in a way, apart from the unboxing, we also thought about the reboxing. Like, how would you put stuff back into it, and how would you like store it for later? And yeah, and throughout the process, we kept discovering different ways to add to the design. For example, once the cardboard was stacked on top of each other, it sort of formed a canvas on the side with a very interesting texture on it. So we were thinking we could do some cutouts in a way that would form a pattern when it's stacked together. And as you can see here, we tried to make a ultrasound pattern first. But this was a bit overwhelming to the eye, so we went with something a bit simpler that communicated the grid system even on the side of the package. And with all those steps, with all that experimentation, collaboration, we finally came to the final design for the packaging. The grid is represented as punched holes on the top and the bottom side of the packaging. And on the top, the grid is used to portray some Japanese typography using cuts in between the grid. So the unboxing of the package starts with a tearaway strip on the side of the package. And as you tear it away, it reveals a poem underneath. In a lot of these strips that you can find in real life, like let's say a package that you get couriered, there's usually like a plastic tape underneath so that as you tear it, it doesn't tear away like a halfway. But we left this out on purpose because, again, not to have plastic at all in the packaging, but we found out it still works pretty well. And once you open the first flap, you present it with the Aizome logo, with the corrugation showing through. And this is done through the process that I mentioned before, which is to cut the top layer of the cardboard and then peel it out. And as you remove the second flap, you present it with the documentation, as well as the directions for use for the vial of the wastewater. And there are 3 different documents inside the box. Of course, they were all designed using the 6 by 6 layout, in which the text, the data, and the visualizations were arranged. First document is a set of 8 flyers that communicates the benefits of using the traditional method of dyeing fabric with indigo. And all this data was printed on a semi-transparent sheet. And the sheet also explains the main problem with the traditional method, which is that if you dye fabric in this way, it fades out over time, which is why this was discontinued. But in the next document, which is a booklet, this booklet is a light blue color. And this document explains the history of how plant-based dyeing was innovated throughout history. And it finally leads to how Aizome developed their process that uses ultrasound to bond the dye to the fabric. And the final document is a poster in a deep blue color. This poster explains the significance of Isome's waste care and shows the benefits of the wastewater produced from the Aizome Ultra process and how it can be beneficial for the skin. So the pin structure in the packaging ensures that the documents are picked up in the exact order as we designed it. And it's also interesting that the first document that you pick up is not colored. The second one is a slight blue, and the final poster is a deep blue. So this signifies the dyeing process over time. And after you take out the documents, you're presented with 3 objects: a vial with the wastewater serum, a pipette, and a sample of the fabric itself. The packaging was designed in a way that each of these objects had like a interesting interaction associated with it. So let's go through it one by one. Let's start with the bottle. So the bottle itself is made with this medical grade vial, which is used for blood testing in some cases. And it's made with a material and it's in a shape in a way that it makes it completely non-refractive. So it allows light to pass through the bottle without bending at all. And we felt that this was a nice metaphor for the transparency. So the liquid that you see in the bottle is not even optically distorted in any way, and that adds to the story, in a nice way. The details of the serum was then printed on the vial. And then the next step was to design a lid that would prevent it from leaking into the package, the wastewater from leaking into the package. Mm, this was an interesting design opportunity for me because there was a number of things that the lid had to fulfill. Like the lid would be quite small, so for that size, it had to be easily opened. Um, then again, we couldn't use any plastic, so the next viable material that we could use was metal. And we thought, okay, we're using metal, then we can add some depth to the lid as an object itself. So maybe showcase it as a high fashion piece of jewelry. And this was quite a fun process. So I tried a bunch of different designs, I played around with shapes, textures, manufacturing processes, and just came up with a lot of options at first. And to move forward, ideally, I would have liked to do some testing for these shapes, maybe 3D print them, do some tests with prototypes. But this didn't really fit our timeline. So we kind of had to take inspiration from the objects we see around us. Objects like this. So the Capri Sun bottle is essentially like a water balloon with a cap on it. And the flat shape of the lid, it offers a lot of control to the user so that they don't just squeeze out the juice while they're opening it. So using that as a validation, we took a certain shape forward and we prototyped it on the 3D printer, and we tested it out. But then even with the 3D printed plastic, which is actually a soft material, we didn't have a good seal on the glass vial. So we thought, okay, we use metal, which is much harder than plastic. It would be even worse of a seal than that. So that's when we realized that we would maybe need one additional part to the lid, which is maybe add a rubber cork in it to make a much better seal. Then we further started developing the shape, and we realized that the end product would be made with milled aluminum and a rubber cork. And after a few different steps, we eventually went on to make the final design. And this was quite fun for me. Like, this is where I could practice some core industrial design, come up with a shape that's simple, iconic, and effective. And the lid also features very simple construction of two parts. It's milled aluminum and a rubber insert. And that completes the story of the bottle. My next step was to go back to the packaging and actually redo the cutout on the box next to the bottle for the lid as well. And for me, doing this revision was quite interesting to see how the design of the lid affected the packaging itself. And that's for two reasons, I feel, because one is like it should feel like it belongs there. So you can see there's this nice, perfect offset around the lid so that the lid fits in perfectly into that. And the offset also helps in a way that when you take out the bottle, there's no obstruction next to the lid, so you don't accidentally open it while you're removing it. And this again is a good place to bring back the topic of tolerances. So what's happening here is two rigid objects, which is metal and glass, being squeezed into cardboard. And again, cardboard bends, it deforms, and again, depending on the direction of the corrugation, it can be really tricky. So there was really a sweet spot for the tolerance here. And because it had to remain tight over multiple times, like as you take the bottle, put it back in, but still, like, it shouldn't be too tight, too loose. Yeah, and again, the number of iterations it took us for this bottle to fit in snug and perfectly was quite a lot. And the next object in the packaging is the pipette. And the pipette is used to take out the serum from the vial. And for this, we were thinking of using, we used a borosilicate glass tube, which is commonly found in labs. So we found a tube that fits the size, it fits into the bottle, and then we asked a glass manufacturer to cut them down to 60 millimeters. We could have used a normal dropper with like a rubber balloon, which is very commonly used in skincare products, but then we didn't want to introduce another material into the mix. and we had a possibility of keeping it simpler, and we went with that. Mm, and this is also another rigid part made of glass that goes into cardboard, but it's also small and cylindrical. So again, it was a different way of thinking than the glass vial of how the tolerance for this would fit in inside the packaging. And of course, one of the things that comes in the box is the fabric itself. So that is the product of Aizome. And we wanted to craft like a easy and interactive way to present this fabric. Maybe in such a way that the user can touch and feel the fabric, but it's also neatly presented in the box. So what we did was in one of the layers of the cardboard stack, we designed a flap where this flap can be taken out and put back in. So this is how the tab looks like in the packaging. We also really like that the pull tab on the left side sort of naturally has a hole in the center, just following the grid system. So even if you take out that part, the grid is part of it. But yeah, you hold it from the left side, you lift out the tab, and then the fabric is in placed in between, and then the user can feel the fabric and also easily put it back with the pull tag. And yeah, that concludes the story of the packaging. This was a result of a hugely collaborative effort between the designers, art directors, our suppliers, and the industrial designer, me. And we try to make a guided unboxing experience where we can take the viewer through a clear step-by-step unboxing process, where they also get to know the story of Isome's innovation. Also, a type tool was also developed to translate the ultrasound patterns into text. And then the grid system was expanded beyond the physical package, but also made for the screen on the Aizome Waste Care website. And yeah, with that, we come to the end of the presentation. Thanks a lot for listening in. I always enjoy talking about my process and my thinking. And also a huge thanks to the entire team that was behind the project. So thank you.
Ashwin, that was so great. Thank you so much. I'm really happy that we got to really dive into the entire unboxing of Aizome because there's so many components. It's crazy. So just a quick reminder to our audience: if you have any questions, feel free to drop them in that box. We'd love to hear from you guys and get some and get some good questions here to Ashwin. So first off, I just kind of want to just know a little bit about you. Like, how did you, really come to industrial design? Like, what drew you to it?
Oh, that's a good question. I mean, I guess I always used to sketch as a kid, and then always used to like make a lot of things with my hand. So luckily, I found out about design, which wasn't very popular at that time. But then, yeah, I really like making things with my hand and sort of like doing crafts and making things real. And I guess along the process, you learn a lot of different tools and processes, but it sort of comes down to that, just making things work.
Sure.
So, yeah. So I guess yeah.
Did you have an obsession with packaging early on?
Not really. Not with packaging. No. I mean, even in this project, a lot of times it didn't really feel like a packaging project. It really felt like I was trying to work with these materials and work on this function, on this interaction, and make it happen. So it was funny in a way that, yeah, how this project sort of landed.
Yeah. So obviously, sustainability is a core value to Aizome. How did you ensure that the packaging did the same?
Yeah, I think a big part of it was the decision of the materials used and the processes used. Like I said, for example, there was this one part where we had to make the structure, and 3D printing worked really well. It was a method called SLS printing, which is great for rapid prototyping, especially if you're manufacturing in a low scale. But then, yeah, we realized that this was the only plastic piece in the entire box, and and we started out with this vision that we wanted the packaging to be sustainable, that follows the story. So I think, yeah, we made those decisions to not have those materials and like work around that constraint. So I think that's how we sort of prioritize sustainability.
Yeah, that's good to also avoid Capri Sun tops as well. But I love that. I love that you took inspiration from that. But that's actually leads me to my next question. Like, where were you kind of taking, like, because it really is like it's such a beautiful design, but I kind of want to know where you were taking inspiration from when you were creating it. Like, were you looking towards the beauty industry? Like, what were you sort of like looking towards, you think?
Um, hmm. I think in a way, I sort of, yeah, we did look at a lot of packaging projects out there in a way, but I feel like the grid system itself was a big way to sort of base our decisions on, because we had the system, the 6x6 system, upon which we could rely a lot to validate our design choices. So, for example, yeah, I mean, like when there's a system, like a clear system like that, we would like entirely stick to that, but not, yeah, maybe not depend on too much on external, yeah, like influences to design it, I would say. Yeah.
Yeah. How many? Actually, this is kind of. I was just thinking about this the entire time because you really kind of went hard on the cardboard. How many layers of cardboard are actually in that box?
That's a good question. I actually would have to count right now, because when we were developing this, I have the thing right here. When we were developing this, 1, 2, 3, we have 9 right now, and 9 of the stacked cardboard layers, and then there's a flap that covers it. This was actually a big topic when we were developing this, because we kept going back and forth between different standards of cardboard. So it really depended on what cardboard we could source and what that thickness was. Because if there's a thickness of one layer, then it multiplies over into separate layers. And then, yeah, I think that's what decided what would be the final number of layers, is what kind of cardboard can we source, and it's easy to plot and manufacture.
Yeah, yeah. I think what's so great about the unboxing is that obviously it really does sort of tell the brand's story, the way everything sort of unfolds. Is that something that you're kind of thinking about as soon as you get a design brief, like how you can kind of like tell the brand story in just a really creative, expansive kind of way?
I think so. I believe so. I mean, I always think that it's always about the story itself. It's never about maybe the product or like the feature that you're trying to say, but it's always about the overarching story. And in this case, it was a collaborative effort where everyone was thinking along the same lines, and we were all trying to communicate the story. But yeah, it's something that I practice myself too, which is to always put the story forward and sort of let everything else follow that story.
Yeah, yeah.
Mm.
I have a question here from Sonia, and that was, what was the touch point of the type tool developed as part of this project, and how does that fit into the Isom brand story?
Mm. So I have to say, like the type tool was not, it wasn't my part of the project, so I wasn't involved in this type of the project. But there was a huge team. I mean, some very skilled people working on that. And basically, in the type tool, you could see that the font was being translated using an ultrasound pattern, and this was used in the documentation in the packaging. So the poster has this font, this type, and yeah. So the starting point was trying to convey this the wave pattern into text, and then having that on the documents, and that's why the tool was developed.
Yeah. How long did the whole process actually take of like, of designing this? Because it seems like there's just so much to it.
Yeah, again, I think my involvement was about 3 months, but then the entire project is much longer than that, and I cannot put a number on that, unfortunately.
Okay,
But
but you can put number on this though, because I you at one point you were like in trying to fit the bottle into the cardboard. You're talking about how many iterations you had to go to. I know you know how many. How many times did it take you to get the bottle?
Well, it wasn't in the single digits.
Come on, give me a number.
I don't remember the exact number, but it was so tricky getting this to work. I think at one point we were even trying negative numbers, like we would actually make the hole smaller than the bottle so that, it would fit in. I think for the pipette, we actually did that. The hole is actually a bit smaller than the pipette so that, the first time you put it in, it widens a little bit. And from then on, it's like the right level of tightness. And it was different for each of these three objects. So I cannot remember how much exactly the iterations were for the bottle.
Can't remember or don't want to remember. No, just kidding. I'm kidding. So Jeremy asks, did you do any shipping tests? How did the box travel and did it hold up during the journey?
So this project, I was involved in the project a while back. We did ship this out to a few the leaders in the textile market, but I was not involved in that step afterwards in the project, unfortunately. And it was not a use case where we would receive the boxes back, where we would see a status of the box after it's shipped. But then the processes we were using, for example, like the stacked cardboard cutouts that we saw at the supplier's workshop. And they told us that this is a common method that's used to transport like technical components to ship it. And usually cardboard is soft. It gets a lot of shock absorption and you sort of dissipate all that damage within itself. So I can imagine the box would have some wear and tear, but yeah, I would be curious to see that. I think it would look nice, actually.
Yeah.
Yeah, without any damage to the internals.
Yeah. One other question I had. So, because I was thinking about you get this amazing presentation when you order it the first time you're learning about the brand story. And I'm not sure if you know this. The second time you order it though, does that come in like an actual smaller package? Because at that point, the customer's already sort of seen everything at once. I just kind of want to know if there's less material involved the second time around.
I think right now the packaging is intended to be sent out to a few select people that can really understand the impact of this and really make a call based on that.
Okay.
Yeah. So the wastewater is recognized for its benefits, but then it's still not a product that we can ship out in a huge scale yet.
Yeah. Well, I think that kind of does it. We got an amazing presentation. Thank you for hanging around and answering all of our questions. Some of mine being really stupid and annoying. Just kidding. So I know it's about 8 o'clock there, so you gotta go to bed. You gotta go out. You gotta do things. So again, Ashwin, thank you so much. This was just a great case study, and I hope we get to hear from you again soon.
Yeah, thanks a lot for the opportunity, and thanks everyone for listening in. And it was really fun.
Great, awesome, man. You have a good night. We'll talk to you later.
Awesome, thank you.